This is June 2016 and paper 2, question number 6. So we've got, this is a hammer just before it hits a nail. The mass of the hammer is 0.5 kilograms. When it hits the nail, the hammer is allowed to travel downwards with a velocity of 3.1 meters per second. I'm still trying to use that circling everything that I need. I think I'm going to need later on. The good thing about GCSE is that it does indicate what the question is going to be about. So the first thing is state the relationship. In physics, the relationship is, it's normally an equation, they will accept P equals m times v, P being the symbol for momentum, m is mass and v is velocity. But you could also write it out as momentum equals mass times velocity. That would be even better for 1 mark. So then we're going to calculate the momentum of the hammer. So we've already written down the equation, so we just need equals 0.5, which is the mass, times the velocity of 3.1 meters per second. This is kilograms. And then we're just going to make sure that the units all work out. So we've got the equation right. And then we can see that this is 1.6 kilograms meters per second. This was a really good way. If you didn't remember what this equation was, you can see by the units that it should have been momentum equals something, and these units would have given you the equation that you would use there. So notice that if you don't remember the relationship, have a look if they put the units, and then you can work out what that equation should be, because it should have been kilograms times meters per second. If it was mass divided by velocity, it would have been mass divided by velocity, like that, which is a very different unit to what we're seeing there. The hammer stops quickly when it hits the nail. The momentum of the hammer reduces to 0 in this amount of time. Calculate the force that causes this to happen. Well, okay, so what do we know? We've used momentum so far. So we're going to have force times time equals the change in momentum. So now force equals change in momentum over time. So it went from momentum before of 1.6, and then the change in momentum, it went to 0, the momentum of the hammer goes to 0. So then that is 0 divided by, and then the time would be 0.07 seconds. So that should lead us to 22 newtons. So this equation, we know that this is impulse, and an impulse is a change in momentum. So we're looking for a change in momentum. Now we could just use this, because the change in momentum between 1.6 and 0 is just 1.6. And then the change in that momentum over the time that it took gets us our force. And the time was that. So I can just use that equation, and then that's going to get me those 2 marks. Remember, if you didn't know this one, you could still do error carried forward, put in a number here, use that in your equation down here, and then that would give you something. As it enters the wood, the nail exerts a force on the wood. At the same time, the wood exerts a nail on the force. Explain how these 2 forces are related. Well, this is Newton's third law. We can state the third law, and that forces are equal. The forces that they've mentioned are equal, but are opposite. So if one exerts a force on the other, they should be equal forces, but they are in opposite directions. Or you could say up and down. So whichever way it's going, one force is pushing it up, the other force is pushing it down. Both ends of the nail exert pressure when the nail goes into the wood. Explain why the nail exerts more pressure on the wood than it does on the hammer. So this is the part on the hammer, and this is the part on the wood. So what could we say? Well, we're asked about pressure, so let's use the pressure equation first. Pressure equals force over area. So forces are equal, because you can't have a bigger force than down here, but you can have a bigger pressure. And what's caused the bigger pressure? Smaller area in contact with wood. So if there's a smaller area in contact, if the force is the same but the area goes down, force stays the same but the area goes down, what's going to happen to P? If that goes down, well, the pressure goes up. And it's because even though the forces are equal, smaller area in contact with that should say wood. Okay, and that's question number 6.